Hello everyone, I'm Bastien from RTE, and I'm gonna talk with you about Seapath again, I'm sorry. And I'm also grateful to see you here after this, all the presentation we had about Seapath. So the idea of this presentation was to show a bit what we do in RTE with Seapath, what's it's our goal, what's are the functionality. At the first, yesterday, Lucian said, we have this magic word, digitalization, and what we wanted to do with this presentation is to show concretely what it means for us. So we're gonna give our point of view, a TSO point of view. We're gonna explain how we use it practically, really physically. And what we're not gonna do is to do a technical presentation. We had this morning a really good technical presentation, so I think it's not needed. And there are also many resources on the web, so you can find it there. And yeah, one disclaimer before diving in. It's only RTE point of view. So Seapath is something really highly adaptable. So what we think about how we want to use it only regards RTE, and you might have a different opinion. So to explain that, we're gonna present two projects, the R-Space one and the VCC. And also we're gonna take an example about how we, about our thoughts, technical thoughts, how we design the network. So a bit of context. I will start easily, and then we will go a bit more into the details. We are a TSO, as you know. The important figure here is that we have almost 3,000 substations. And where is Seapath? Seapath is in the substation. I wanted to start by this, even if it's obvious for most of you, because when we speak about virtualizations, many times people think that we virtualize, so we put everything in the cloud, but that's not the case for Seapath. So Seapath is inside this little building where there are all the materials. So inside the substation, second obvious thing, so we use Seapath for PACS, or for SAS, or DSAS, or PRC. All these acronyms means the same. It's the protection, automation, and control systems. That's the one I'm gonna use. And in the substation, we have the high voltage devices. We connect them to control them to some base. And all these bases are linked together to a central system, and that's where Seapath is. So, first message I wanted to give is that today in RTE we have one substation that uses Seapath in operation since last year, since November, if I remember well. And this solution is our space program, and it's a multi-vendor solution. Meaning we have different IDs from different vendors, we interconnect them, and it works. And it works thanks to the 16850 standard, because we define the data model. That is, by the way, it's open source as well. I haven't put the link here, but you can find it easily with a simple Google research. And this project, what I wanted to tell you about, it's that it's an industrial one. Meaning it's not a proof of concept, it's not a prototype, it's a project that is running on since 2017. And we also think about all the tools we needed to deploy it in an industrial way. So that's why we work on it since that date. And this project we use Seapath. That's my point here. And we virtualize some function of the substation, basically three. You can see the bay level on the right side, the station level on the left one, and the three functions we virtualized is one, the SCADA, second one, some automation, and third, the gateway. We're gonna look more in details what it means. And it runs on 3 physical servers. And yeah, basically that's the architecture. We've got some merging units, and we still have some IDs, and the Z under one, meaning distance protection function. So the protection functions are still in IDs. The SCADA looks like this. One interesting thing about this is that it's running on Windows. even if because it's running on Windows, we have high need of CPU and resources. But what I wanted to say here is that Seapath can run a Windows virtual machine, and it works well. We have done this choice because the software we use, we wanted to be able to configure it using 61850 files automatically, meaning that all the drawing here is generated automatically based on some scripts we developed. We have another view. It's the bay view. If you want to get more in detail, we can. The second function we virtualized is the some automation. Here we have two examples. For example, the alarming automation. These automations only makes the alarms soundy. We can hear the alarms when someone is in a substation. It's a pretty basic automation, but that's one we developed. We developed this automation in RTE, and we built all the virtual machine with the Dockers you see here internally as well. And second automation, for example, is switch breaker failure automation. For the one who knows, when you have a circuit breaker that fails, it triggers the other ones that are close to energize the circuit breaker in failure. So yeah, and this automation, they have some cycle timers about. We have two families, let's say. One is the slow one. It's every 80 milliseconds. It calculates, and the other one is every 10 milliseconds. And we can allocate all the functions. In RT, the function is a LD, LD for logical device in the 61850 language. And we can allocate the function in the Dockers as we want. If the function is critical, we isolate it in the Docker. If a function needs to have interface with others, we group them in another Docker, so we can do basically what we want. And last function we virtualized, actually for the pilot site it's not the case, but it will for the next ones. It's the gateway. The gateway is only something that translates between two protocols, the 61850. It's the protocol used inside the substation, and to communicate with the control rooms we use the 104 protocol. And physically it looks like this. We have a little building, and all the pack system is in this building. So what we want to do next? This project, RSpace, it was an industrial one. Now we are launching a new project called VCC, for Virtualized Control and Command, or VPAC. And what we want to do is that all the protection functions that were in the IDs at bay levels, we want to host them in Seapath. So in Seapath, at the end, you will have some virtual machine provided by RTE or others, and you will have also some different virtual machine provided by the vendors, basically. In order to do that, we launched a tender this year to ask our partners if they are okay to provide us this kind of software, because we are not going to develop that internally. So yeah, I wanted to say something about this. We talk a lot about virtual IDs. We don't want to use virtual IDs, because when you talk about virtual IDs, normally you think that this is an IDs, but we want to group several IDs in one virtual machine. So if we talk about virtual IDs, we may think that one virtual machine equal one virtual IDs. And that's not what we want, because we want to limit the number of virtual machines on the system. So doing that, what are the challenges that we're going to face? First of all, the most obvious one is the performance challenges. We've seen some really interesting demo yesterday, but the virtual protection has to work with the same performance level than the physical one. And as well, it's not only about the protection itself, it's also about the whole system. So the network as well will have to reach this needed performance. We talk a lot also about deterministic behavior. Distance protection is a safety protection, so we want that it trips when it's needed, and we want that it doesn't when it shouldn't. And this we're gonna need to test it to be sure that it's working well. And as well, the big something we talk about these 2 days. It's as we ask to provide some software, and we provide the hardware. How do you test that? What's the limit of responsibility between the hardware provider and the software provider? That's a whole topic we're gonna dive in with this new project. Now, regarding the architecture, the good thing with virtualization is that we can do whatever we want. It's much more flexible. For example, we can have a 5-node cluster. That's the architecture one. And in this cluster, you can have 2 different virtual machines. And one for the main protection, Z under one, and the other one for the backup. But we can also imagine to have a hybrid system with IDs functioning with virtual machine. That's the architecture 2. And that might be a transition between the fully IDs architecture to a fully virtualized architecture. And we also could imagine to have several clusters. That's the architecture 3. So we see that as an opportunity because it's really flexible. And what I wanted to say here is that Seapath, we can do that. It's adaptable. But when we do that, we centralize virtualization, meaning centralization. So we need that with this centralization, we have the same level of availability. So we're going to make some calculus, we're going to make some tests to prove that, and to be able to convince people internally and externally. And the same thing goes with the sharing hardware with different functions. When you have the same hardware running and VM from different vendors, how are you sure that the one virtual machine won't impact negatively the second one? Now I'm gonna let the microphone to Florent, because he will talk about how we saw the network performance challenge and how we try to solve it.
Thank you. Yes, this is a kind of use case of how we solve the problem, or how we define an architecture in Seapath. So it's more an example of how we help developing Seapath. And the thing I understand with virtualization is basically we have to think everything different. We have to think cybersecurity differently. We have to think system management and differently, and everything is different. And for networking, of course, we go into in the universe of virtual networking, many words, many things, many ideas, many solutions. But so first thing we hear is we hear a lot of SRIOV, we hear DPDK, we hear HSR, PRP, we hear BPF or XDP or that kind of things. And so the question we ask ourselves is basically, what is our target for guests? So basically, virtual networking for guests that have no real critical needs, networking needs, standard networking, virtual bridges, like Erwan talked about just before, Linux bridges, OS bridges, they are fine. What if you have a need for performance and resilience? That's the question. An IED right now, he receives sample values, for every milliseconds, so it has to be very performant in its reception of sample values, very resilient. It cannot lose too many sample values. So there are different solutions right now in the physical world. What happens when we go in the virtual world? That was the use case I'm going to present to you. So we want to virtualize a protection that needs to receive all sample values with low latency, no loss, and preferably in order. How do we do that? So before we go into the solution, I'm going to try to explain the different words so that you have a primer on virtual networking, ultra basic, one sentence per, per technology, just to set the tone. What's DPDK? So DPDK, libraries, so some code, to accelerate networking by basically doing it in user space. You don't go in a kernel, and you bypass the kernel. You do everything in memory. You may need a driver that pulls the data in memory, so a dedicated CPU, dedicated RAM, huge pages as we call them, some specific software, OVS is compliant for instance, but yeah, that kind of thing. Basically the idea is you do the networking stack in user space, and you bypass the kernel, and you avoid any bottlenecks because of that. What's HSR and PRP? This is different. This is not about performance. This is about resilience. The idea is that in industrial networks, you may need to have zero loss of packet. You can't afford to lose a packet. In that case, you may want to use that technology. They're basically the same. The idea is we duplicate every packet, and they go different ways. And in the end, we deduplicate the packet. We ignore if we receive the double. So the difference between HSR and PRP, HSR basically, when you have a loop topology, you don't need any switch, for instance. You don't need any hardware. You just connect the machines together. And one packet will go in one direction, the other packet will in the other direction. And in the end, the recipient node will just deduplicate and only keep one. For more devices, you may want to use switches. In that case, you go to PRP. PRP, you have two different networking paths, LAN A, LAN B, with different switches and everything. Everything is independent. And so every packet is duplicated on one way and the other. And the idea is you can lose this cable, you can lose this switch, you can lose everything. As long as you lose only one, the other node will receive the packet and you will have zero loss. So yeah, this is the idea about HSR PRP, resilience. Two other things, you've heard them in the past if you've seen the other talks about it. PCI pass-through. The idea is that you're gonna map a physical port of an hypervisor directly to the VM. So this is very performant, kernel bypass, everything. The only problem with that is that if you have 15 VMs that need networking, you will have to dedicate 15 physical ports to the host. So this is not very scalable. And for that, kind of new technology that happens is SRIOV. SRIOV, you do some PCI pass-through on steroids. The idea is that you can virtualize the same physical port onto different VMs. And you have some internal bridge, this is called the VB, that knows where the packet should go on reception, depending on VLAN ID or a unicast MAC address. So this is very promising. We'll look into it. Last slide about this primer. eBPF. So eBPF is a framework in the kernel that allows you to run some custom code directly in the kernel. So it's totally the different approach as DPDK. It's the contrary, basically. So we keep being in the kernel, but we optimize by creating an express data path that bypass most of the functions we don't need, because we know the traffic is always the same. We don't have to go into routing or whatever. So we bypass it, and we create a specific network stack inside the kernel. So same objective, going faster and less latency, different way of doing it in the kernel instead of outside, instead of trying to bypass it. So let's talk about resilience. So you understand that in all technologies I presented you, only one is about resilience, PRP and HSR. It's basically right now the only real alternative for zero-loss networking. This is a standard. It has been developed for industrial networks. It's kind of a standard for the actual physical ID. A physical ID usually has two network ports, one for LAN A, one for LAN B, and deal with and has a PRP adapter or a PRP logic inside to do this deduplication. So even if you try to virtualize this IED, the resilience will probably have to go through PRP. So it's a question on how the IED will deal with that. There are two ways, the hardware way and the software way. The hardware way is basically to buy a network card that has two adapters, and that will create an abstract virtual card, which is redundant, basically. And many vendors propose that kind of hardware. And we have an in-kernel module, so a software way of doing it inside the kernel. And we're going to look into it. Sorry. So this is about PRP. So let's talk about DPDK. DPDK is basically the first thing that comes to mind when you come from the embedded world or from the big multimedia world, because every time you think about having a low network latency and a high throughput, DPDK is usually the solution. It's a way to go. The problem is that DPDK is pretty heavy, like I said. It needs a pull mode driver, it needs a dedicated CPU, it needs a memory switches, it needs a specific stack of drivers, of software. So it's kind of heavy. At the same time, I talked about SR-IOV, and it looked pretty simple. Okay, you can just virtualize this network interface to the VM. So why would I care about DPDK? So the current idea is that you usually prefer SR-IOV for south-north traffic. So, but since you are virtualizing a physical network, it will be very interesting for the traffic that goes out and in of an hypervisor. Usually you will go that way. For something that will go from a VM to another in the same hypervisor, then it will be interesting to bypass the kernel. It has no interest of going out. It's inside the hypervisor, so we call that the east-west traffic. And in that case, usually DPDK is preferred. In our use case, like I said, the idea is that receiving simple values coming from a merging unit, a physical merging unit, into a VM. In that case, we are definitely in a south-north traffic case, so probably SRE will be better. So our first approach in this study, it will be to try if we can find something simpler than DPDK, and SR-IOV looks like a real nice candidate. So, SR-IOV is our new hope. The promise is for a guest to use the network directly, but for multiple guests to also be able to use the same network directly. So our architecture basically would look like this. We have a standard bus in the substation with PRP, as usual, and we have the two different network paths, LAN A, LAN B, and we want to connect the VM to this PRP network. For that, we imagine that the idea would be the hypervisor will be the one connected in PRP to the two networks, and then every VM that needs access to this PRP network will just have to plug. It's a virtual function to virtually plug to the adapter. And so basically, every VM will have one virtual card on the physical. The virtual import card A will be on the physical card A, and B would be on B. And the VM would see basically the both networks, LAN A and LAN B, and then we have to do the PRP logic inside the kernel, so with the Linux kernel I talked about, and the application would be in basically the same way that it was before, having LAN A, LAN B, both traffic, PRP doing the deduplication, network summing in. So it looks very nice. And the first time I looked at a virtual IED I was sent to test, it was basically how that worked. I had to configure in the IED what's my LAN A network interface, what's my LAN B network interface. And the VM would deal with the PRP logic. But it's not that simple. It didn't work very well. Erwan said it before, talking about weird latencies. What we find is that basically it's a mono-threaded application. This kernel module is mono-threaded, so it does everything in one thread. And because of modern interruption framework and architecture in the system right now, like MSI-X frameworks, it's very easy for a packet to be handled with different CPUs and arrive at the kernel out of order. In this kernel module, if the packet arrives out of order, it will be dropped. And so basically, you will have to rely on the upper layer, like TCP, to resend the packets. It would create huge latencies. We opened we sent an email to the net dev, so the network development mailing list of the kernel. We had no answer, and basically it's because this module is also orphaned. There is no active development maintainer. The problem we have with it is very deep in this architecture. It will have to be redone completely, basically. So we found it would not be a very good idea to use this kernel module in production, and it wouldn't work anyway. And the second deal breaker we have is that if I show this stream again, this would consume CPU, of course. This would consume CPU, and if you have 15 VMs would have to consume the same CPU to deduplicate the same PRP. So it's really not scalable. Like I said, doing PRP in kernel consumes a lot of CPU. So basically, we'll have to look for something else. We need PRP. We can't do it in software. Conclusion, logical conclusion, it has to be done in hardware. And that's basically where we are now. We would love to use SR-IOV to share the physical interface directly to the guest. That's a real promise, but we know PRP must be done in software, and no vendor provides yet, I heard rumors, but no vendor provides yet a hardware card that would first deal with PRP to provide this redundant abstracted NIC, and this virtual NIC expose it to the VM with SR-IOV. That would be the dream, but actually it doesn't exist yet. So imagine this is a call to vendors, do it, please. So in the meantime, we have to share this redundant NIC that is provided by the hardware PRP to the VM differently. It can't be done with this SR-IOV. So our first approach, and current approach, is to use a basic OVS bridge with some tap interface using VOSnet. So it's a VRTIO, it's power utilization, pretty performant. And we assume it's the most simple architecture you can have doing that. Because basically this seems complicated, but basically it's a network card, so you just buy it. Then it goes to Open vSwitch, which is free and very simple. You create a bridge and you tap as many VMs as you want on this bridge. Like Erwan said just before, we have concern. We know there might be some performance issue if you go into certain conditions with a lot of traffic, and you may need for that to dedicate some cores to the VM to avoid those issues. We'll have to look into it. But for now, we haven't had any real problem with it. We know how to solve the issue, and it looks scalable, and it looks especially simple to put into motion. So what's next? Like I said, this is the current situation, but we would really hope to have a vendor, or better, multiple vendors to provide hardware that do the PRP and SR-IOV at the same time, so that you don't, basically, everything would be done here, and the VM would directly tap to this card. No kernel. That would be exceptional. And we think it's a real target to investigate. If we don't see that soon, then we can look into XDP. You remember XDP is the framework in the kernel that does the express data path that you can optimize what the packet will do in the kernel. So we can look once again here. This is a big logic, and Open vSwitch can even be slower than a Linux bridge because it can do a lot of things. But if we know this is multicast packet and they go to all VMs, for instance, so it's similar to broadcast, this logic maybe is very simple and could be recoded manually with an XDP program, and so very performant. So we could look into that too. And in the end, if all else fails, then we can look into DPDK for the same thing. How can we optimize this packet switching function with DPDK? So those are the three perspectives we have on this network, virtual network issue or study.
Thank you, Florent. So yeah, as you've seen, we didn't want to talk too much about technical, but we can't help ourselves, I guess. So just to talk a bit, to step back or step aside to see what Seapath is and what goes with it. It's been said this morning. It's a purely IT/OT project, IT/OT convergent project. The use case is for OT functions, and it's a pure IT projects. I mean, the technology that's used, it's purely IT. You've seen it. So it's been discussed this morning. I don't want to say more than what Christophe said, but one thing important in IT OT conversions for me is that it's a change of culture. In OT world, before working on Seapath, I was deploying some conventional pack system, and when it was deployed, the rule number one was when it works, you don't touch it. And now, with all the software elements, we have to update, and maybe not daily, but we have to update quite often. So this will take time. I don't have the solution how it's going to change, but it's a change that is needed. Of course, we need some new skills we could develop, but I think it's not the most important thing. Another thing we want to do with Seapath is that we want to industrialize it. I told you we have 1 substation in operation. We're gonna have 2 more this year, and we want to go quicker. Basically, in RTE, because of aging assets, we have to renew 500 base every year. So we can do it by hand. That's why we industrialize it. We want to industrialize it to earn some time to go quicker, basically. And one thing we want to do is to be able to configure Seapath or part of it based on the 61850 SCD files. And one important topic as well we discussed yesterday, and we will discuss, I think, in the years that are coming. We want to ensure the long-term maintainability, because those systems they are running 24/7. They will run for many years. So all these softwares we need to maintain it on the long term. So to conclude, Seapath is not about the code. It's not only about the code. It's not purely virtualization. It's not something monolithic. It can adapt to many situations. And to us, it's much more a tool than a product. It's at the intersection of all these things we talked about. The market shift from hardware to software. We have high diversity in the users. Vendors, TSO, DSO, and that's great. That's an IT/OT convergence project, and also we have to develop a whole market of application running on Seapath, because today we have some prototypes. We launched the standard, but a whole commercial offer needs to be built. And yeah, and with Seapath we want to be able to renew our assets. So yeah, that's what I wanted to conclude on. It's that Seapath is at the intersection of all of that. So thank you for everyone for listening, and we are here for your question. Yes, Daniel? So you've been experimenting with SRIOV a lot?
Hi. You've been experimenting with SRIOV so far, and have you noticed anything with regards to determinism, as it was called all the day? Because you basically have an infrastructure where you've got multiple I/O queues for different virtual PCIe functions, and the VMs accessing that, they do not know about this. So for them, it's just a physical interface. Like, is there a can you prioritize the traffic in some form, or I don't know. Was the question clear, or?
So the answer is that I don't know. Honestly, we've gave up with SRIOV pretty soon. So we didn't have time, or we didn't look into that because well before we decided that it was not an option. Like I said, because the in-kernel PRP was not an option, SRIOV was an option. SRIOV would have been an option if resilience was not a problem. When resilience is a problem, you need two SRIOVs, and so you need to deal with this PRP problem. And we didn't find a way to do that with SRIOV. So basically, we found out that okay, SRIOV was nice, but not enough. We had other issues with SRIOV. Like I said, there is a VEB bridge that dispatches the packet to the VM. In the norm, it can only use VLAN IDs or MAC address, basically. And it's an issue for us because we don't want to create a VLAN architecture based on the VMs we want to put in the hypervisor. That has no sense. And so using a unicast MAC address has still no sense because we are only doing a multicast with SV and Goose traffic. So we didn't have time to look into that too, but I assumed it would have been a problem also, and that we would have had to do some multicast, and basically every packet received on the card would have been broadcasted to all the VMs. I assume it would have finished like this. But like I said, because we couldn't deal with this PRP problem, we didn't move far enough to answer your question.
Mr. Kanabar, thank you so much. It was a really nice presentation. Question I have, like when we started LFE, Seapath project, at the beginning, I think it was make architectural decision to go for the Yocto version. So my question is about moving from Yocto to Debian. Have you made decisions already, or you are investigating Debian versus Yocto? There's a pros and cons either approach we go to, but I think getting into the Yocto more, and have a more control, more customization, allows us to make it, the purpose fit for the real-time type of workloads. Is that something in your thought process, or you're trying to make Debian work whichever way it's possible, or try to optimize the Debian only?
So yeah, we made the move to Debian. The first thing to say is that we are completely agnostic about what's inside a VM. So a VM can be running Yocto, can be running BSD or Windows or whatever. It doesn't matter. So for this, we have absolutely no preference. For the infrastructure, I come from IT. So basically, I was expecting things like LVM and that kind of things, and so I was personally more comfortable with a streamlined operating system. And for now, we haven't had any things we couldn't do with Debian. So you told about customizing the kernel. Usually you can do that with a sysfs or configuration or sysctl rules. So we have been able to do all the customization we needed. Debian comes with an RT kernel. So for now, like you said, Yocto is highly customizable, but it comes with a price. You have to understand it, understand the language, etc. And so there is a gain, there is a price. In our use case, the gain wasn't worth the price. But basically, it really depends. Like I said, Seapath is highly customizable. In another use case, it might be the contrary. So.
My second question is, you make a decision of going Debian only, or you're still going to check?
No. For now, I'm the maintainer for the Debian branch. So basically, every use case we have, every need we have, I'm the one responsible to implement it with Debian in Seapath. So yeah, the choice for us, we stick with Debian as long as we don't hit a wall. we'll keep. And the first site we have in production is running Debian. The two new sites we are deploying this month are also running Debian. So for now, we have no doubt about this, and the decision made. If we don't hit a wall, we will keep it that way.
First of all, congratulations on a very interesting presentation. You mentioned that you're using SRIOV for communication, peer-to-peer communication within the virtualized system. Does this mean that you're always communicating via the network stack? And if that is the case, did you also consider using a Linux bridge or vSwitch for the peer-to-peer communication within the virtualized system?
Thank you. So now for the communication between the VMs, it's a nice. I didn't say about that. I didn't talk about this. Right. No. The idea for us is that if it's not critical, I mean, if you don't have any performance issue, if it's not 4,000 sample values a second, and for now we haven't had this problem, we will use standard networking. And since OpenVSwitch is quite nice, has a lot of features, it's free, so we will stick with OpenVSwitch as much as we can. So basically a bridge. We have been using Linux bridges. Only in one case, I don't remember. Yeah, only for the external administration interface. We didn't want to have OpenVSwitch in the middle of it. It was a recovery access, a rescue access. So we didn't want to have OpenVSwitch in the critical path. So in this case, we use the basic Linux bridges because we are sure it will work. OpenVSwitch for the communication between the VMs. And we haven't had the case of two VM with highly performance needed networking, in which case my slides say we would look into DPDK for that, because it would be east-west communication, two VMs discussing in the same hypervisor. For now, we don't have the case. So basically, every internal communication, every peer-to-peer communication, like you said, OpenVSwitch. Yeah.
Hi, thank you for your good presentation. I have another question about one slide about the HMI. Can you tell us a bit more how you achieved that the HMI was generated automatically, and are there any technologies or standards that already are commonly available for that?
So this is a commercial product. And basically, Bastien said this is running on a Windows VM, and so we are using a commercial product, and the commercial product has this heavy client. And so what you see is basically a remote desktop connection to the VM. So this is not linked to Seapath at all. Seapath is only hosting a VM and giving access remotely with network. You connect to the VM, you launch your tool. It can be anything. So this is not generated by Seapath. This is just remote desktop.
But just to complement the answer, is your question about the single line diagram in a digital substation, more generally speaking? Okay, we have a lot of open source code on that. You should see what is the possible project. Have you ever heard about that? It's power system blocks, library sets. So it's POWSYBL, possible. It's in LF Energy, and you will have a lot of algorithm that's doing the job, open source. So, yeah.
Yeah, but for our space, we didn't have time to redevelop our Scala, so we basically bought one.
Yeah. So first of all, yeah, very interesting topic. Also, the networking part. Can you comment a little bit on the physical layer? What type of cards, speed, and you're using for that? So to look for what is the generation of the network cards.
Yeah. So this is really at a POC level, at a proof of concept level. So we didn't have to go into many details. Like I said, the network card, basically two things, PRP and SRIOV. SRIOV, most cards, I think about Intel i350 or X710, that kind of chipset, they do SRIOV, it works great. So we've used both, and for our use case, it worked. Like I said, we had a doubt about this VEB that does filtering based on VLAN, and we didn't look into that too much because we were blocked before, and we thought it would have been a problem, but not because of the hardware, it's because of the SRIOV norm directly. The other thing is that might be interesting, for an industrial environment, I don't think there exists an SRIOV chipset that supports high temperature. So that would also be a deal breaker. Maybe you may comment on that? Okay, so thanks, Joss. So just from Velotech. No, what I've tried is I think it's one. It was 1 gigabyte or 2.5 kind of things. Maybe you know just what speed we are waiting for this new card.
Would be 1 gigabit or 2.5.
Yeah, that's what I said. So basically 1 or 2.5. So we're not that high. But yeah, right now, if you want to have SRIOV, you wouldn't be able to host it in a substation that takes the sun too much. So that would be a problem. We have the same problem with RAID hardware. This is not about networks; it's about disk resilience. But we have the same problem with RAID hardware. If you buy a RAID chipset, a RAID adapter, some vendors have them. They won't support over 55 degrees. And if you want to keep 70 degrees, you can't use SRIOV. You can't use RAID basically. And the second thing is PRP. And PRP, what I can say is that it exists for high temperature. Velotech has one, and it basically works. And in the end, it's not even our problem. Like I said, we plug the card, we can configure it with some web interface, and then it's transparent. I mean, the operating system sees one NIC, it sends the traffic and receives the traffic, and once again, it's not Seapath's problem anymore. So PRP, we're pretty happy. It's pretty easy. SRIOV, we won't use it, but we couldn't at that time. We couldn't because it wouldn't support temperature anyway. And let me conclude by redoing my call that we really need to try a PRP plus SRIOV card. And if it exists, we would look into those VLAN and a unicast MAC address issue, but it would deport all the complexity to the hardware, and so we won't have to deal in software. Does it work? Ouais. Well, thank you very much.